Hello dear learner, welcome back to the Zoom Chemistry Hub. Today we will discuss most important short answer question for all board exam from the chapter Chemical Equilibrium. The first question is that define chemical equilibrium with two examples. The answer is the state of a reversible reaction during which the rate of forward reaction becomes equal to the rate of reverse reaction is called chemical equilibrium state. Means when the rate of forward reaction and the rate of reverse reaction are equal, then this state is called chemical equilibrium state. Example is that when hydrogen react with iodine in a reversible chemical reaction, they form the hydrogen iodide, and then the hydrogen iodide will reverse back into iodine and hydrogen. Similarly, in the Haber process, nitrogen react with hydrogen and they form the ammonia gas, and the ammonia gas in the reversible will convert into hydrogen and nitrogen. Next, question number 2. How would you identify that dynamic equilibrium is established? So we can identify the dynamic equilibrium. How? Dynamic equilibrium can be identified by knowing the concentration of reactant and product at a regular interval of time. When the concentration of reactant and product are observed constant, mean to say when at any point when the concentration of reactant and product are constant, then the reaction is said to be in dynamic equilibrium state. So when the concentration of reactant and product are observed constant at any point, then this state is called dynamic equilibrium state. Next question number 3. Write the macroscopic characteristics of forward and reverse reaction. So the macroscopic characteristics of forward and reverse reaction are is under forward reaction. First point, in the forward reaction, it is a reaction in which reactants react to form product. In the forward reaction, product is formed. While in the reverse reaction, it is a reaction in which product react to form the reactant. In the reverse reaction, reactants are formed. Similarly, in the next point, a forward reaction takes place from left to right. It takes place from left to right. While for reverse reaction take place from right to left. From right to left. Next point, in the forward reaction, at the beginning, the rate of reaction is very fast because there is no product, only the reactants are present there. So the reaction are very fast in the forward reaction, while at the beginning the rate of reverse reaction is 0 because there is no product, only the reactant is present at the beginning, at the starting point. So at the beginning the rate of reverse reaction is 0 or negligible. Next point, in a forward reaction, as time passes, it slow down gradually. As the time passes, the forward reaction slows down gradually because the products are in the process of formation. While with the passage of time, the reverse reaction speed up gradually because the products are formed gradually. Next question, question number 4. Relate the active mass with rate of chemical reaction. What is the relations of active mass with the rate of chemical reaction? So the active mass is the molar concentration of reacting substance in reactant. Mean to say, in a reactant, the substance or the mass which are in the process of reacting, this is called active mass. Higher the active mass of reactant substance, faster will be the rate of chemical reaction, and smaller the active mass of reacting substance, slower will be the rate of chemical reactions. Mean to say, if the active mass concentrations are higher, the reaction will faster, and if the active mass concentration is slow, the rate of chemical reaction is also slow. Next question number 5. Write information which is required to predict the direction of chemical reaction. So what are the information which is required to predict a direction of a chemical reaction? So the answer is to predict the direction of a chemical reaction, first we calculate the reaction quotient. So reaction quotient is Q, and reaction quotient is equal to the concentration of the product divided by the concentration of reactant. Then after calculating the reaction quotient, that is the concentration of the product and the concentration of the reactant, the calculated value of reaction quotient is compared with the known value of Kc. So if reaction quotient Qc value is equal to Kc value, the system is in equilibrium. The system is in equilibrium state. If the Qc value is greater than Kc, if the Qc value is greater than Kc, the reaction will proceed in the reverse direction, and if the reaction quotient value is smaller than Kc, the reaction will move to the forward direction. Next question is question number 6. What is the effect of temperature on equilibrium state? So in an equilibrium state, when we increase the temperature, or when an increase in temperature favor the endothermic reactions, which shift the equilibrium in the forward direction, while a decrease in temperature of a system favor the exothermic reaction, which shift the equilibrium in the reverse direction. So with the increase in temperature, the reaction favor in the endothermic and the equilibrium will shift in the forward direction. And when the decrease in temperature, direction favor the exothermic, and the equilibrium will shift in the reverse direction. So that's for today. If you like this video, please like, subscribe and share with your friends and fellows so we can grow each other. Thanks for watching. We'll meet another interesting video. Till then, Allah Hafiz.